Oh, you bet. I have a ranch. Okay, so this is a fourth root times a fourth root. Are you allowed to multiply them?
Absolutely not.
Since they have the same kind of root, yes, you're allowed to multiply them. And you do it just like we did on the last problem. You go ahead and multiply them together. That's not the trick to this problem. So I'm going to have a to the what? Yeah. C to the, and C to the 20th. Okay, now, where I'm worried that you may have forgotten this is how do you break down a fourth root of 48 in particular? Look at it. Go back where you belong.
Boom. We need those charts.
You have to find a number which goes into 16 that's a perfect fourth power.
We need those charts.
Not only have you write it all on your card. Guys, think about it. You have to go, what's 2 to the 4th? What's 3 to the 4th? 2 to the 4th is 16. 3 to the 4th is 81. Well, 81 is too big, so what's the only one that can go in a fourth root? This is a fourth root. 48 is not a number to the fourth power. You have to find, just like when you break down square root of 63, you say square root of 63 is 9 times 7, and you pull the 9 out to make 3 times square root of 7. So here, if I want to break down 48, I got to find a number to the fourth power that goes into 48. Which, the only one we've got is 16, because everything else is too big. The 16 go into 48. 48 is 16 times 3. Now, think before you answer. When I take 16 out of a fourth root, what will it become?
4 squared 3.
What to the fourth power makes 16? 2. So when you take it out, it becomes a 2. And the 3 hangs around inside. Okay. A's, do you remember the easy way to do variables? They were quick and easy.
Yeah.
Yeah. Divide the 4 into each power. 4 goes into 12 how many times?
3.
And it goes in evenly, so there's no remainder. How many times does 4 go in 17?
3.
4. Which would be 16, so that means we have a remainder of 1. And C goes into, or 4 goes into 20, sorry.
6. Oh.
5 times with no remainder again, so we have nothing left inside. Are you done?
Yeah. Shut up over there.
Something you have to check for.
Absolute value.
Absolute value. Remember good old even, odd?
No, sure.
You had to, it might be that some of these variables, we have to make sure they're all positive, because even roots assume that all numbers will come out positive. Can you guarantee me that A, B, and C represent positive numbers?
Yes. No.
No, you can't. So, if they do not meet the even, odd rule, you have to slap an absolute value on them to make sure they will be positive. Okay, so the first even was that you had to have an even index, meaning the power, the root, the type of roots had to be even. In our original problem, both 4s were even, so yep, that qualifies. Anybody remember the second even? It's the power it had on it on the inside. So in this case, since we started with 2, we'd have to look at both of them. Were both A's even? Nope. Were both B's even? Nope. Were both C's even?
Yes.
They were both even. Did they come out odd?
Yes.
C came out with an odd power on it, so it would get an absolute value because it met all of the conditions. So it has to be an even power when it's inside the root and turn out to be an odd power when it's outside the root.
You have to record this for the other class too?
Nope. They were all here.
No.
And you guys are choosing different problems later.
So how do you do on 2 different powers to the beginning?
You talking about 11?
Yeah.
I won't work the old thing here, but if I, on 11, if you have a, whoops, help if I have something right. If you have a cube root times a fifth root, what did you have to do? You had to make them common roots, just like you make common denominators. What's in common to 3 and 5? 15. So you're going to make them both become 15th roots. What's in that first one? F4Z. Okay, so how did you make the 3 become a 15? You times it by 5. So you times every power inside by 5.
So, 5 is...
So F to the 20th and G to the 5th. And you keep going.
Bingo.
12 and 13, not hard, but you have to remember the secret. The way to make it easy. Do you want 12 or 13?
12. No. 13.
13? Okay, it's basically, this is the same problem as we did over here with the number 8, all the A, B's, and C's. This is the same problem, except your powers are fractions.
I put them in square root.
They could go to a square root, but that's actually the hard way on this one. I need to multiply the top together. Okay, but technically that 7 is to the first power. So you'd have to go, how do I add negative 3/4 and 1?
What?
How do you add negative 3/4 plus 1? You're scaring me. Because you have to take a common denominator. So you got to make sure everything has a common denominator. My suggestion to you was when you did these, just before you ever start, just make everything have a common denominator. So what would be in common? The 3/4, 1/4, and 3/2.
4.
4. Yeah, so let's turn them all to fourths, which means the first one's just fine. Okay, but this 7, that's a whole 7, 7's the first power. How does that become fourth?
0 4.
Nope. That's 1 as a power.
4 4.
That's 4/4. And then, okay, on the bottom, 3/2 is going to become 6/4. And I also need to distribute that to both of them. So I'm going to write a 7 to the 6/4 and x to the 6/4.
You read that?
Now, combine the top. What can you put together? Negative 3/4 and a positive 4/4 would make 1/4. And then the bottom just hangs around here. Now it's an up-down deal. Which way do you want to move what? We're bringing the 7 down. So if I bring it down, that would make it become a minus 1/4, or I would have 7 to the 5/4 on the bottom. Okay, which way would you like to bring the x's? To keep them positive. I'm also bringing those to the bottom, so I'm going to bring 1/4 down as well and subtract 1/4 from 6/4, which is going to get you x to 5/4 as well. So I'm going to have another x to 5, or another 5/4 I should say, on the bottom with an x. What's on top? 1. Go team.
Jump for joy.
Okay.
That was awkward. We did it.
Why was it awkward?
Just Cody thought it was funny. I'm just tired. Uh-oh. Break.
Why are you ridiculously tired?
Oh, tell me.
Because I don't
You want a prom cookie? Why are you tired?
You didn't stay up to wait for those who went to the prom, did you?
What?
Did you stay up till like 2 a.m. when they got out of Dr. Prom?
No. I got there at 9.
He probably went home and played.
Shut up.
Okay, next page. I want to do either 15 or 16, your pick.
15.
Let's do
16.
16.
The clock means I have to join the same side.
Well, he was a smart pick.
Negative.
There's a negative on it.
Just a negative.
Okay, now, notice the instructions for this problem.
No calculator.
No calculator. Your first page of the test will be some graphing questions, and one that pertains to this stuff that you'll do with no calculator whatsoever.
Oh, what? That ain't fair.
Then you use calculator.
calculator for the rest of it.
So I'm asking you with no calculator, nothing but a brain, to figure out 32 to the negative 2/5 power.
Well, we're all gonna do it.
Okay, you do
Two's on the inside.
2's on the inside.
Yeah.
The 5, the 3.
So that means the 5's on the outside, but what's the negative make you do?
Flip it.
Mhm. Yes, it's 1 over. It goes to the bottom. 2's on the inside. 5's on the outside. Now, you don't have a calculator, so I doubt you want to square 32.
Don't you like
Can we just do
do
32
the
times
cross
32?
on
You want to do the root first. What's the 5th root? What times itself 5 times makes 32? It's got to be something mighty small. 2. So yeah, that becomes 1 over 2, and now it's just squared, which you can do with your brain, and get 1/4.
That was easy.
So I will make it some numbers that are easy to figure out. I'm not going to give you something hideous, horrible that you'd have to calculate huge numbers. If you always do the root first, you'll make it small, and then it's easy to take it to a power. So, alright, that's that one.
Wow.
17 and 18 is another one, and you tell me, remember it or not. How do you solve equations that have a root in them?
Square root both sides.
Did you do the root on both sides?
You have to get one root isolated on one side, because how do you get rid of roots?
Square root.
You gotta keep it,
You have to square it. You have to square both sides if you want to get rid of the square root. So, you gotta get one root, the root isolated and then square both sides. Now in 18 there's 2 roots. So that makes it a little more interesting. So, do we need to do one of these or not?
Yeah. Can you possibly give me a copy of the test?
No? So 18 is the choice, is that it?
Yeah.
Okay. 18, anybody remember what I named these?
ultimate form.
These were ultimate problems, yes.
That explains the space.
Then you guys still have
Yes, Stephen, that explains the space. Although this one isn't as ultimate as some of the ones I made you do. And something nice is going to happen in this one. So, you all said you want to square. Can I go square each one of those separately?
No.
No, you can only square whole sides.
Yeah.
Hey, you can, but you wouldn't get that in.
And so, don't write this down. If you squared both sides, you would have to square that entire left side, which means you would have to FOIL 2 roots.
Ain't that bad.
We did that before.
Wouldn't you have to square the same one?
You would have to, you can only square sides. You cannot square them separately. Totally.
Like square the negative too? Like,
You would have to take this entire thing times itself and FOIL it.
I know, but would you also have to square the negative?
Yes, you would. But, would you really want to square the roots? FOIL those 2 roots together? There's an easier way. Yes, you want to move one of them to the other side. You want to separate the roots. Which one's logical to move to the other side? And the negative one, you would probably want to move it to the other side and make it positive. So we have b plus 4. I'm going to add b plus 20 to the other side. And then there's still a minus 2. Or you can write it in opposite order. You can do negative 2 plus square root of b plus 20. Doesn't matter what order. Then you square both sides, which you've got them separated. So, square your left side, that's a toughie. We get b plus 4. If I square the right-hand side, I would be doing what? I would be FOILing. So I would be taking this all times itself. So you're taking it times itself, which means a full FOIL, all 4 parts. What do you always get when you take a square root times itself? Cancels the root and you get the inside, so you just get b plus 20. Okay. Outside. I'm taking negative 2 times that square root. And the negative 2 is going to stay on the outside. It's not going inside, so there's really nothing more you can do than write it down. But what amazing thing always happens on the inside, when we do inside. I get exact same thing, and then I'll get negative 4, yes, so that's square root. Then last, negative 2 times negative 2 is positive 4, and I need to pause it.